How to graph a trig function. When given the function f of x is equal to sine 2 sine of x minus 1, the first thing I'm going to do is look at the amplitude, frequency, period, and midline. To determine that, I'm going to use the standard form of the function a sine bx plus c. Knowing that and comparing the values of my given f of x function, it makes it easier to find my amplitude, frequency, period, and midline. To find my amplitude, I'm going to look at the a value of my function. In this case, the absolute value of my a value is equal to 2. The amplitude will give me the height of my graph. The frequency is going to be equal to my b value. In this case, we don't see a b value there because it's just 1. The frequency of 2 sine x minus 1 is equal to 1. The frequency, remember, means that from 0 to 360 degrees, we will be able to complete one full sine curve. The period is how long it takes to complete one full sine curve, and for that I take my b value of 1 and put it over 360. This gives me a period of 360 degrees. The midline will be my c value. So here my c value will be equal to -1. I can then take this information and compare it to the basic parent function sine curve shown here. Here in blue, I have the basic function sine of x. If I start off by looking at my 2 sine of x, I can rewrite and find out what those points would be if I had the function 2 sine of x. That's going to be, remember, a change in our amplitude. So each output value will be multiplied by 2. So my starting point would be 0, 0, 90, positive 2, 180, 0, 270, negative 2, and 360, 0. If I went ahead and plotted those points, I would get a curve like this. So that has shown our vertical stretch that is occurring within the graph. I now need to take a look at the second piece of this graph, which is going to give us our vertical shift, our shift in our midline of -1. From here, I'm going to take each of the points from my 2 sine of x, and I'm going to shift those down 1. This will be my final complete answer. So I'm taking this point here of 0, 0 and shifting it down 1 space. So now my starting point, instead of being 0, 0, is 0, -1. This red point up here at 92 gets shifted down 1 space and is now going to be at 91. I do the same for the rest of my points. 180 now becomes a -1. 270 now becomes a -3. And 360 now becomes a -1. If I plot the remaining points here of 180, -1, 270, -3, and 360, -1, I can see my completed sine curve function. From here, I can also double check my midline, which remember is the c value. If I was to draw a line at y equals -1, we can see how my sine curve here oscillates or goes up and down along the line y is equal to -1. This graph was done completely by using my parent function sine of x and knowing my transformations and how a change in amplitude, frequency, period, and midline will shift the graph. If you're using your graphing calculator, there are a couple of important things you have to make sure you're remembering. If you're given the problem using degrees, like we currently are here in this problem, we want to make sure the mode on our calculator is set to degrees. We then need to change our window so that it includes these numbers. Finally, we can change our table so that our table is going to go start at 0 and change by values or intervals of 90. Now, as we go further in this unit, we're going to talk more about radians. And radians, remember, is just another way of measuring an angle measurement. If you're using radians, change your mode to radians and change your window to these values. And also change your table. Making both of these changes, or all three changes in the mode, the window, and the table set, you will be able to get a complete graph for your trig functions.